Good day, guys. This is Newton's second law question. It says two blocks of masses 5 kg and 3 kg respectively are connected by light insensible string that runs over a frictionless pulley as shown in the diagram below. The 5 kg experiences a frictional force. There's a frictional force there. There's an Fk. And the coefficient of kinetic friction between the 3 kg on the surface of the inclined plane, it's 0.15. We're told about the description of the surface there, which is it's a mu k. We have a mu k there, which is 0.15. Guys, in the diagram there, this is a system. It accelerates to the left, the 5 kg, and the 3 kg, it accelerates down the slope. Remember, it has one acceleration. We choose that direction as positive. That means up the slope is negative, and the 5 kg left is going to be negative. Right? Guys, before we go to the question, let's just analyze the forces and see what are the forces that are acting on these objects. Let's choose another pen. On an inclined surface, you have a normal force that is perpendicular to the surface. We have a gravitational force, which is perpendicular to the surface. It's Fg perpendicular. And we have the Fg, which is the normal Fg. And we have Fg parallel. Fg parallel is always down the slope, guys. Always down the slope. And since the 3 kg it's moving, and there will be a force that opposes the motion, which is the kinetic frictional force and the tension force as well. Right? Those are the forces that are acting there. Let's look at let's use another pen. At the 5 kg, there's a normal force, there's a gravitational force, and there's a tension force in that direction, and there's a frictional force in that direction. So these are the force diagram, guys, of each of the forces. It's very important to do this when you are writing in the question paper, to analyze and write the forces there. Now let's go to 2.1 as a definition. I'm not going to waste time on that. It says define the term frictional force. The frictional force is a force that opposes the motion of an object that acts parallel to the surface, and it's a contact force. Guys, when it comes to the definition, stick to the exam guideline. 2.2, it says draw a free body diagram to indicate all the forces acting on the 3 kg block. Guys, I already drawn the forces and show the forces there, but remember, on an inclined surface, guys, you cannot show all the forces there. If you have indicated this Fg there, you don't have to indicate the components there, but I'll advise you to use the components. Guys, the best thing to do is to resemble the incline by the broken line and the box by a dot, and we have the normal force, and we'll have the Fg perpendicular. Remember, the normal force and Fg perpendicular are equivalent, and we'll have Fg parallel to gravitational force that is parallel to the surface. We'll have the tension, and we'll have Fk there. That's the free body diagram. Remember, guys, it's very important to know the forces, and the free body diagram, it guides you. Okay, 2.3.1. It says calculate the magnitude of frictional force acting between the 3 kg and the surface. The 3 kg is the one that is in the inclined surface, guys, remember. So they want the frictional force. Remember, guys, they were given the mu k of the 3 kg, and we can find the normal force, which is the normal force I told you that is equivalent to the Fg perpendicular. So we can use this formula that says Fk is equal to mu k times normal force. But what you need to remember there, guys, the normal force is equivalent to Fg perpendicular. Yeah, and then it will be the normal for the Fg perpendicular, it's mg cos theta. You need to remember that, guys. Now let's substitute. You only get 1 mark for these, guys, 1 mark for any of that. So it's going to be 0.15 multiplied by the mass, it's 3 kg times 9.8 cos 30. We're given the angle there, guys. You need to punch that in the calculator. Let me put that on my calculator. It's 0.15 times 3 times 9.8 times cos 30. So the answer there, it's, let me double check, times 3 times, yeah, it's going to be 3.82 newtons. Frictional force there, it's 3.82 newtons. Right, let's go to the last question, 2.3.2. That says calculate the magnitude of the tension force of the tension T in the string. Remember, guys, we are not given the tension there. So the tension that is experienced by both objects there is the same, but in opposite direction. So, guys, if you look at the mark allocation of this, it's 6 marks. You have to use the simultaneous equation. And guys, if you're not given the acceleration and they're asking for a tension, you have to first get the acceleration, and then after acceleration, you will get the tension. It's a simultaneous equation. Guys, in the simultaneous equation, let me use another pen. In the simultaneous equation, you can start to create an equation of any of these objects. Let's start with the 5 kg. You see, I label it's 5 kg, and then I said F net is equal to MA. Right? So in the F net, I'm going to do all the net, or the sum of the forces that are acting on this object or the forces that are involved in the motion of this object. So our Fk there is going to the left, is going to be negative, and plus the tension. Those are the only two forces that are acting on the 5 kg is equal to Ma. And then the frictional force there, we were given the frictional force of the 5 kg, it was 8, but since it's negative, it's going to be negative 8 plus T. Tension force is the one that we're looking for, and the object is 5 kg, and the acceleration we are not given, we're just going to times by A. So we're going to make T as the subject of the formula there. So we will have that as the first equation. Now I'm going to the 3 kg, the one that is in an incline, the 3 kg. Now you see I indicate which mass I'm dealing with now. Now the F net, now it's going to be the F net of the forces that are acting on an object. It's going to be those forces. So we have up the slope is the tension and the frictional force. So it's going to be negative friction minus the tension. Remember guys, another thing that if your tension in the first equation was positive, and then your tension in the second equation, it needs to be negative, right? Hope you get that. Now what is the other forces? Fg parallel. Fg parallel is going in the positive direction, so it's going to be plus Fg parallel Ma. Now let's substitute what we have. Do we have the Fk of 3 kg? We do. We just calculated that. It's going to be negative 3.82 minus the tension, it's unknown, plus Fg parallel, it's mg sine theta. So it's going to be 3 times 9.8 sine 30 is equal to, the mass is 3 and the acceleration is unknown. So guys, what I'm going to do, I'm going to say this plus this on a calculator. It's negative 3.82 plus 3 times 9.8 sine 30. So the answer there, we're going to have T plus the answer, it's positive 10.88 is equal to 3A. That one we can leave it like that as long as we dealt with the unlike terms. Guys, in the simultaneous equation, there you can use various types of simultaneous equation. You can use an addition, you can use an elimination, you can use the addition, elimination, substitution, any. So guys, we leave it that as equation 2. So now what we're going to do, we're going to substitute equation, I'm using the substitution, equation 1 into equation 2. So let's substitute. Let's take the equation 1 and we substitute it at T. Remember, these are 2 terms and this T is negative. I have to open bracket and says 5A plus 8 plus 10.88 is equal to 3A. I hope you get that, guys. When you distribute, the negative is going to be negative 5A, negative 8 plus 10.88. Guys, that's math. So here are the like terms there. So it's going to be negative 5A plus 2.88 is equal to 3A. And then we transpose there, it's going to be 8A equal to 2.88. I hope you get that math. And we divide by 8 both sides. So we'll say 2.88 divided by 8, it's 0.36. So this is the acceleration of the system, 0.36 meters per second squared. We're not done yet, guys. Told you, when you want a tension, you have to first get the acceleration. And then now we get the acceleration, we're going to sub this acceleration into equation 1. You can sub in any. You can sub in equation 2, it's going to give you the same answer. Remember, equation 1, it's T is equal to 5A plus 8, and then we substitute that acceleration there. It's 0.36 plus 8, 0.36 times 5, 0.36 times 5 plus 8, it's 9.75 newtons. That's the tension, guys, that we have there. Guys, that was the last question there. Thank you so much. Cheers. Bye.